5% wrong. 2.5% of the time, because you're too high, 2.5% of the time, you're gonna be too low. So that means you're gonna have 2.5% in this right tail. You're gonna remember right tail area, 0.025, that's 2.5%. So you go down to however many degrees of freedom you have, in this case 19, 20 minus 1, so the answer is 2.093. Very good.
And then you do
Let's do this one, please. So this is the stuff you need.
Oh, you already did that?
And then the 2.5.
Yeah, I already have calculated. You got 0.0357.
Okay,
Yeah.
Okay. Oh, yeah, you did. You have it right here. So it's 0.0.
And my thing is the calculator, but we getting this calculated.
You can use this calculator. See, over here.
Oh, and you do?
Press the second.
Okay. Did I keep the same? I like it. Yeah.
Huh?
Yep.
Getting it from, it's all how we buy it.
Once again, we just leave the numbers like this on the round.
Okay,
Don't
so I'll look at it.
I remember you said keep it on the base, and then take the second.
All right, should we do this first one?
Wait.
Ready? All right. So in this case, we want to know the average price of a gallon of gasoline.
Yes.
We do some sampling, 20 gas stations. We find the average price in that sample is $3.506, $3.50. We are not given the population standard deviation, as we would not be in the real world, so we calculated it ourselves. We take those 20 samples, we put them all in Excel, do the formula for sample standard deviation, and we get 0.16. So we are going, for our confidence interval, to take our point estimate of 3.506 plus or minus some number of standard errors. Standard errors we'll calculate the same way. What number of standard errors? Well, it's going to depend on this new t-distribution, which is going to give us a wider interval than we are used to. So let's start here. This t-distribution, 95% confident, 5% of the time we're going to get it wrong, 2.5% too low, 2.5% too high. Degrees of freedom is 19, 20 minus 1. So what do you come up with for the t-value?
2.093.
Alright, is everybody happy with the way we got 2.093? Alright, let's calculate this standard error. The sample standard deviation divided by the square root of the sample size. What does that come out to?
0.0357.
0.0357.
7.
7?
Yeah. It
Okay.
was 12 minutes.
Excellent. So we want to take 3.506 plus or minus 2.093 times 0.03577. Okay. What does that part come out to? What is our margin of error?
0.0748.
Okay, I like that. About 7.5 cents. Pretty tight margin of error, given that we don't know anything about the population standard deviation. We only had a sample of 20. All right, what is our confidence interval then come out to when we take 3.5 minus
0.603.
So this is $3.50, this is 7.5 cents. This is gonna be about 343 something.
Exactly, 3.432.
Okay, and what's our upper bound?
3.58.
Oh, yeah, what you doing?
Okay.
I'm late, huh?
Excellent. Alright, and the interpretation.
So I am 95% confident that is it still true? The true, not population, the true sample?
Now, the true population mean,
Okay, the true population mean
yes,
is between 3.432 and 3.58.
excellent, perfect. Alright, the reason Amanda hesitated there, she's like, does this still work the same way? Yes, it does. Still works the same way. You can still say we are 95% confident of the true population mean. The reason why it works the same way is because we added a little extra cushion to account for our lack of precision based on not knowing the population standard deviation and adjusted for our sample size. And we calculated the standard deviation ourselves. But we can still interpret it the same way, and we can still say confidently we are 95% confident.
So on the lower end, if I got 3.4311, would you have been okay with that answer?
3.4, that's a bit off, that's
No, on the
13
other-
cents off.
On the other end.
You got 3.4,
411. 3.4311.
3.43,
11.
that sounds good to me.
Yeah.
Okay, so the next part said if the sample size was 10 instead of 20, how would that change things? Let's do that. Okay, so this instead of 20 gas stations, now we're at 10 gas stations. Alright, so what's gonna change?
Degrees of freedom.
Degrees of freedom is gonna
So
change,
the T-score.
T value is gonna change, very good.
Everything.
Alright, now this standard error is gonna change, because now we're gonna do the square root of 10. Okay, and the margin of error in the confidence interval, of course, is going to change. Very good. So what is our new standard error? 5, okay. 0.0505?
9.
9?
Yeah, that's it.
0.0505.
Okay. Okay, our degrees of freedom changed. We're now at 10 minus 1, which is 9 degrees of freedom. So what is our t value if we still want to be 95% confident?
2.262.
Excellent. All right, so we're going to go 2.262 times 0.05059. All right. What is our margin of error going to come out to?
0.1144.
Very good. About 11 cents, 11.5 cents. Still a pretty tight estimate. So when we take $3.50 minus 11 cents, what do we get?
3.39.
And
3.6.
He said 3.39.
3.62?
Yeah.
Yeah. Mhm.
Good. Good. I like it. All right, who wants to do the interpretation?
But 95%, 3.3.
All right, so we're still looking for the true population mean. And how confident are you?
95%.
All right, so take it from the top. Start with I'm 95% confident.
95% confident that the margin is true population.
All right, so you're 95. We're looking for the true population mean.
Right.
So you're 95% confident that the true population mean
Is 3 to 3.6, 3.2.
is between these two numbers.
Right, to 3.29.
Very, very good. Okay, good. One thing let me draw your attention to in this problem. Did you notice the sample size in this problem? It started out was 20 gas stations. Did that alarm anyone?
Less than the.
It's less than 30. That's a problem. We cannot necessarily assume that the sampling distribution and the sample mean stuff will work unless what?
It's 30 or more.
Unless it's 30 or more. Also, there's another exception that I mentioned earlier tonight that I said was going to be slightly relevant tonight.
If it's a normal distribution,
If the population it comes from is normally distributed. So it tells us, assume the population distribution of gas prices is normal.
So then that's okay.
Yeah,
Of it being less.
what we did is okay.
Yeah.
But if you don't know that it's normal, it has to be 30 or more.
Yes, it has to be 30 or more if we don't know that it's normal. Now, in the real world, we might do things to try to figure out if it's normal. We would say, is there anything skewing the distribution of gas stations? Is there like one monopolist who's doing something weird with the pricing? Or is it like a complete random spread based on large numbers and random probability? If it is, then maybe we could say, all right, let's assume that the distribution is normal in the whole population, and let's use the sampling distribution and the sample mean stuff. Okay. There's the next one I think is a good problem. It's just a very simple one that allows you to do a little bit of the calculations yourself, but it comes out nicely and it allows you to practice calculating standard deviation. It is page 256, number 34. There we go.
Mhm. Because it's a sample. It's not the whole thing.
We had to do that big math.
Did you say fake math? Did you say that?
I said a big math.
I thought you said fake math. That's just
What
fake
is it,
math.
fake?
How you doing, Roger? All right, we can average 130. All right, so turns out sample standard deviation is pretty easy to calculate. So you know why I set it up like this, right? Because the difference between the mean squared, add those all up, divide by the total, minus 1. So this is negative 10 squared. This is 0. And this is 10 squared. So this is 200 divided by 2. It's going to give me 100. The square root of 100 is 10. So the sample standard deviation is going to be 10.
So that's already that number. Thing under the end.
Yep, yes.
No, I did it the other way.
And the calculator. Double.
You did 200 divided by 1.
Okay.
Divided by. Square root.
So I do have one more time.
No, it's not the standard error. It's the standard deviation.
Right. Now, what's
All right, maybe the answer, that just comes out to 10. The answer is 10. You got the intuition right. So now figure out what is the,
He said no, not the phone. So the phone is not listening. And I don't know how to say it. I just figure out how to, I gotta figure out this one.
the whole thing is square root. So you need to take 200 divided by 2.
That's the standard deviation.
All right, let's just do this together. I think because the math is fairly simple, it gives you a good understanding of the nuts and bolts of this, but I don't want you to get stuck on the math. So let's just do it all together. In this case, we've got 3 data points. So that's going to be interesting later, because we'll say, wow, we're calculating a whole population mean just on 3 data points. Well, yeah, we can do that. We have a much wider confidence interval, but we can do that. Our 3 data points are 120, 130, and 140. We calculate the mean, add them all up, divide by 3. We get a mean, sample mean of 130. We are not given sample size 3. We are not given the population standard deviation, so we need to calculate it ourselves. So, sample standard deviation, average distance from each of the 3 data points from the data center. In this formula, remember we divide by n minus 1, going to make it a little bigger. So our mean is 130, so we take the difference between the first data point and 130, square it. We don't care so much if it's positive or negative, so that's negative 10 squared is 100. 130 minus 30 is 0. 140 minus 130 is 10 squared, so that's 100. So we have 100 plus 0 plus 100 is 200. We divide by 3 minus 1, which is 2. So 200 divided by 2 is 100. And what's the square root of 100?
10.
Yes. Alright, so that equals 10. So we now have our sample standard deviation of 10. Alright, so now we can calculate our standard error. Standard error is sample standard deviation divided by the square root of the sample size. 10 divided by the square root of 3 is what?
5.7735.
Alright, 5.7735. I like it. Now if we want to be 95% confident, and we have a sample size of 3, what is our degrees of freedom? 2. So we need to look for 2 degrees of freedom. And again, 95% confident, 2.5% in either tail. What would be our t-value?
4.303.
Alright, 4.303. So we have all the components we need. We've got our sample mean of 130, plus or minus some number of standard errors. How many standard errors? 4.303 times our standard error, 5.7735. Okay, what does our margin of error come out to? How much?
24.84.
Okay, 24.849. And then what would that make our lower bound to our confidence interval?
105.15. And 154.84.
Excellent. All right, who would like to do our last interpretation of the night? Joanne?
95.
We are 95% confident that the population mean is between 105.15 and 154.84.
Perfect, absolutely right. She said population mean, you don't have to say true population mean. I just say that for extra reinforcement, but it's the population mean. So, we got a reasonable estimate for just a sample size of 3, right? Considering this population may have been as big as 1 million, and we're able to say with 95% certainty that it's between 105 and 154. That may help us, it may not. Not sure. Good, any questions? Great work tonight. I'm really happy with where everyone is. This is the kind of nitty-gritty of the class, and once you've got this, you're good. Alright, next week we'll talk about something that's very similar to this. We'll do proportions, but it's just this looked at a different way. And then after that, we'll get into things that you'll need to know this, and if you do, it'll be much more fun, much more rewarding. Sounds like you, more fun. Assuming it has to be fun to begin with. It can only be more fun if it's fun to begin with. Good. Yeah, but really use this week though to just really sink in. Let it sink in with some practice problems, homework problems. Email me if you have any questions. And we've got some time. I'll be here, for a little while if you have any questions you want to go over tonight. Otherwise, I'll see you next week. Thank you.
Monica, you already got the,
Yeah.
right? It makes a big difference. 'Cause I was-
Sure, now I can use it. Well, that's half the battle.
I know. It's just, okay, I spent a week all week on it.
I didn't have any time to do
I'm
anything.
using vacation time from work.
Okay,
So
okay.
you gotta use vacation time, you gotta,
I need a vacation from family time. How about that?
okay.
It's not even work, it's
I lock
home.
myself in the room.
I can't.
No.
I'm taking care of my 85-year-old grandmother, and she comes and her walker, she's like, Sarah, what is it?
Oh, I live with my 89-year-old grandmother, but she don't like anybody to take care of her. She is like so independent. She's insulted if you want to take out the trash. So I have to deal with being okay with like she doesn't need my help. So you have the other. When somebody needs her, she don't need her. And then she thinks she don't have to. I want water and watch it.
And then I have my son that's diabetic, but then I have to still give him shots every day. And I'm like,
Remember, we do have to be here.
it's 90.
I think he
allowed us to use whatever we want.
Computer.
Yeah.
Memorize
Maybe doing
everything.
some crazy. Yeah.
He used to have the pump. And now he has no stomach fat, so we used to have to put the pump back here. It has no fat. It kept coming off, so that was an issue.
Have a good one.
So now he's just on the needles. Hey, have a great day.
Make sure you get home safe.
The states inside, the long needle.
He has a fear of needles, that's number one. He doesn't like
Yeah,
needles.
but it's not, it's very flexible, you don't even.
No.
My niece and nephew have it, that's why I was saying.
We've done the needles, we did the needles for like almost 8 years. So it's like the tubes, he just wanted to be free from it all, because it kept malfunctioning.
Yeah, I think that's.
They love it because they just program what they need.
Exactly, it's easier, but when it was just coming off, like every other day, it was an issue, so. You know, I said, let's take a break. I'm trying to, want him to be independent of me, but it's still the same thing. I still have to, monitor and give him
You're
shots
always
now.
gonna be monitoring this, my prices, yes, she goes crazy, like they're 19 now.
Yeah,
And she's still, but they have the automatic.
at least with that, I knew he was getting insulin 24 hours. Now, he doesn't even check himself.
Yeah, like, do it for the time they get old, they got older, but if you don't put the information in the pump, still doesn't do it. You still
Yeah,
have to do it.
no, but at least with the pump, they get the continuous.
Right.
They
But
get
they
at
still have
least.
to, you don't take care of it, I'm just saying.
But he knows when he's high, he knows when it's low. But I'm like, you still have to check yourself. But I'm not complaining, I'll take that over cancer, so, I told him, we can live with this. It's just a life adjustment. All right,
Take care.
have a good weekend. All of that.
Tomorrow, I'm just pushing bed.
How many classes?
Three, 4 p.m. So they were on the end of class. Joanne, do you want me to throw this stuff out?
Yeah, there's not that food. Is my ZK roll in there? Did you see it?
Like the whole process to do it?
We'll count how long it took you to do it.
No, but the quick,
Well, I was right. I mean, he doesn't look at. Where's the house? So he doesn't, he'll give you credit. I would have said, friends and Susan, these are,
Okay, quiz 2.
Yes.
Sorry.
No, don't worry.
Thank you, Chris.
See you next week.
Alright, Joanne, yeah.
So, so I
Oh,
was,
let's go. Alright, go.
remember the problem?
Yeah.
So what I did was I looked at that we needed 90.
Alright, let's take a look at your other test. Oh,
I'm so cold, I haven't, I think I haven't chilled, that's why I'm like, lethargic.
Great attempts.
Is that a peak coat? Or is that a new style of peak coat?
That is
It's a peak coat, right?
You got 2.26.
Yeah, but the right answer is 2.28.
That's,
You
that's
see?
not-
Oh, okay, fine. Because I just want to show you, it's because I use negative 1.29 instead of negative 1.28. If
That's
I,
fine, yeah, that's fine. That's
I'll give it a point.
fine.
Okay.
Yeah, I don't know, I misunderstood. Sometimes, yeah, sometimes it's weird, I can't, like when I'm thinking of one thing.
All right, I was just.
So we
because I
get
was-
credit for it then?
Of course
If
you
we
get credit.
answered,
Of course.
But how would you know? Okay, fine.
Well, that's, yeah, that's,
It's like literally two digits off. Like if I would have multiplied by 1.28, I would have gotten
so
two.
it's 2%. Usually I'll say if within 1% is close enough. You're within, 2/100ths of 1%. And in fact, I told you to use negative
1.28.
1.28, which is what you use.
No, I
No,
used
use
negative
1.29.
1.29.
And I prefer 1.29,
Really?
yeah.
Because that's what I thought. Because based
Yeah.
on the Z
Right.
table, if you see it right
Right
here,
here.
this is where I got
Yeah.
the
Good job.
1.29.
So I should change this for
Okay.
future classes.
If you,
That's
awesome.
all thanks to your good work.
Well, thank you. I listen. I'm trying.
so when I get my grade, I'm not gonna get a grade, I'm gonna be Xed out, right?
Let's take a look.
It is freezing. Bundle up.
All these classes that they're putting
I live in the city, but I'm going to my parents in
What are you doing over there, Carol? What do you need help with?
Looking at my grade too, because I do the same thing, I use the same thing.
let's give you a half point off just for fun.
No. Give me the point. Where in Westchester?
Hastings.
Oh, really? Hastings on Hudson?
That's where you
Hastings
live.
on Hudson. I live in Hastings on Hudson.
That's where you live.
Really?
Yeah, I've been there for over 20-something years.
River Point?
River Point
Yeah,
is,
by, off of Dudley.
is
So
that
we
Fraser
go up
Place or Fraser?
Broadway,
Mm-hmm,
almost, or south on Broadway, almost to Yonkers. And
okay,
then Dudley will take you towards the river.
okay.
Yeah.
So you're down on where, you know who lived over there too? Was
Jump in
the,
the extra.
I did it, I actually got it right, but I, because I eliminated stuff.
I got it wrong.
The guy from SPNN,
Special,
sports channel, he's a sports announcer.
okay.
He's right over there, by me. So you live one of us on the.
Bye, good job, Wendy.
Thank you.
Yeah, my parents live in the condo.
Did you grow up there? Or so you probably live in that little condominium, the little townhouse community, right?
Yeah, it's like a row of condos.
Yeah.
Overlooking the river.
Mm-hmm.
Yeah, they like it there. They've been there since 2004. And where are you?
I'm in Hastings, I'm by Farragut Avenue. So
By
when
the
you get,
school?
by the school.
By the
More, no, more towards, the sawmill. I'm right on the sawmill, I think my house faces the
Your
sawmill.
house faces sort of north on the north side of Farragut or
On,
south side?
on the north side.
Okay. And do
No,
they-
wait, no, on the south side. So if you're going to the city, I'm on the south side.
Okay, so the cars drive by your house really fast?
Yes. No, not really. I
Okay.
don't do very much. You know what, I've come used to it.
Okay.
And my husband grew up in Crossbar, which is in Europe, where your parents live.
Oh, great.
It's right by the Andrews home.
Yeah, I just drove by, actually, I was coming back from the Dobbs Ferry campus, and I
Okay.
drove right by your house tonight.
Right, because if you get on the sawmill, you drive by my house. My house is one that's set up really nice. Yeah, no, my kids went to school there, my husband went to school there. So I had no choice, we had to buy a house
Your
there.
kid, yeah, so you pay those insane property taxes, right?
Oh my God.